This is example 3.14 in your textbook on page 106. It reads, 5 road graders are used in the construction of a highway project. The operational life T of each grader is a log normal random variable with a mean life of 1500 hours and a coefficient of variation of 30%. Assuming the statistical independence among the conditions of the machines, the probability that 2 of the 5 machines will malfunction in less than 900 hours of operation can be evaluated, and they go ahead and do that. I think this is pretty straightforward. You can read through that, and we find that the probability that they ended up calculating is almost 6%, so it's 0.594. For the 5 machines taken collectively, the actual operational lives of the different machines is shown in the figure. Machines 1 and 4 have operational lives less than 900 hours, as illustrated here, and machines 2, 3, and 5 have operational lives greater than 900 hours. The corresponding probability of the sequence is p squared times 1 minus p cubed. But the 2 malfunctioning machines may happen to any 2 of the 5 machines. Just because the operational life determined here doesn't mean that they can't malfunction, regardless of whether they're under or over 900 hours. Any 2 can malfunction. Therefore, the number of sequences, in other words, number of combinations of the 2 malfunctioning machines among the 5 is going to be the binomial coefficient. So we've got 5, and we want to know any 2, and this is equal to 5 factorial divided by 2 factorial times 3 factorial, which is 10. Consequently, if x is the number of road graders malfunctioning in 900 hours, then the probability that x is equal to 2 is going to be simply the binomial coefficient, 5, 2, times the probability raised to x times 1 minus the probability raised to n minus x. So we already determined that this was 10. The probability we got from the first part of the example, so this is 0.0594, and this is going to be squared times 1 minus 0.0594, and this is going to be n, 5 minus x, so this is 3, so this is cubed. So we get the probability that exactly 2 road graders malfunctioning in 900 hours is equal to 0.0294. The next question is the probability of the malfunctioning among the 5 graders, in other words, there will be malfunctions in 1 or more machines, would be, so in this case, we want the probability that x is greater than or equal to 1, which is going to be equal to 1 minus the probability that x is equal to 0, right? X equal to 1 or greater is the same thing as 1 minus the probability of everything less than that, which is x is equal to 0. This is a lot easier to calculate. So we say 1 minus, now this is going to be the binomial coefficient of 5 over 0, excuse me, in this case, times the probability raised to 0. So this is going to be 1, this is going to be 1, times 1 minus the probability of n minus 0, which is 5 minus 0 for this problem, which is 5. And this simply boils down to 1 minus the probability raised to the 5th power. So this is 9406, and this is raised to the 5th power, which, when we crank that out, is 26.4. Whereas the probability that there will be no more than 2 machines malfunctioning within 900 hours would be no more than 2, in terms of probability notation, would be x is less than or equal to 2. Now this, we need the summation, because we're going to sum from k equals 0 to up to 2, because we want to know all of the discrete points up to and including 2. So we sum 0, 1, and 2. And this is going to be equal to the summation of our number of trials is 5, and the times that we take it is k for each of the individual. This is our probability p raised to the k, and then this is 1 minus p raised to the 5 minus k. And I won't write all of this out, it's done in your textbook, but ultimately this simply boils down to 9981.